Let's look at tan x now. So tan x as a function, it looks something like this. So it's able to take in all the possible inputs other than the odd multiples, right? It can't take this, it can't take this, it can't take this. So the graph is just this, just this, just this, right? So it can't take in this set of values, that is odd multiple of pi by 2. And what are the range? What is the possible output? Well, it will vary from minus infinity to plus infinity. So this is going to plus infinity, this is going to minus infinity. Okay, so we have tan x mapping any given angle excluding odd multiples of pi by 2. It's going to map all of these values to all the real numbers. Well, all the real numbers basically. So I can just write it as real numbers rather than this. So tan inverse of x can map real numbers to angles excluding odd multiple of pi by 2. So that's the conclusion. Now graphically, how does it look? It looks something like this. So we have, well, that's my dot, so it can move from minus infinity to infinity, right? And there is a breakage, so clearly the breakage can be seen and all of that. So what are your domain? When it comes to this, domain is clearly real numbers. Now what is the range for this though? What can be the range? Well, range, we have a lot of possible set of values. To make it a function, we need to pick up the branches. So picking up values from the branches is what we're looking at. So let's look at different possible branches. So branches, each of it covers all the possible output values. So basically we are looking at minus 3 pi by 2 to minus pi by 2, such values. So we have minus 3 pi by 2 to minus pi by 2. Then what else do we have? We have pi by 2 to 3 pi by 2, right? Such values are there. Of course, let me go systematically. So minus 3 pi by 2 to pi by 2, minus pi by 2 to pi by 2. So we have minus pi by 2 to pi by 2. If I keep going, I'll get pi by 2 to plus 3 pi by 2, so on and so forth. So which can be the principal branch over here? Yes, that's our principal branch. So we have it from minus pi by 2 to pi by 2. Please note that it's not square brackets, it's small brackets, right? The reason being, it cannot take up this set of input values. It goes to infinity. So graphically it looks something like this. So this is your domain basically, and this is your range, and say I take this as pi by 2, and this is, so there is a gap of 1 to 3.5, 1 to 3.5, it will come over here actually. So that would be your minus pi by 2. Okay guys, now the graph would look like this actually. I need to draw a line which is parallel to your x-axis, passing through your minus pi by 2 and over here too. This is known as asymptotes. That is a line that represents that the graph is trying to reach but will never reach. So basically this is going towards minus infinity, and that's going towards your plus infinity. So your graph will look like this. Okay, so I'll just write that off. range or tan inverse of x. So these are your asymptotes. If you guys want to understand what is this exactly, web search that. It's not there in your books per se, but yeah, I would like you guys to, it's written in the graphs though, but they have not mentioned it, so I just thought I'll let you guys know. So they represent lines, this represent values which the line or the graph tries to reach but will never reach. Okay, yes. Yeah, you can pause and have a look at the graph and write everything, of course.